So welcome to my talk on the future of machine learning and JavaScript. My name is Asim Hussain. You can find me on Twitter, everywhere actually. You can find me on Twitter, YouTube, GitHub, LinkedIn. I'm Jaw-Ache, not Joashe, Jaw-Ache. I've got a new website, asim.dev. I got the dev, yeah? Day one, very early, very happy about that. So I've got my new website, asim.dev. You can find me there, and I've got various things, articles on JavaScript, courses, books on JavaScript, etc. And I'm also a cloud developer advocate, cloud advocate at Microsoft. Applause was for me. I'm a cloud advocate at Microsoft. Actually, in fact, yeah, now I lead advocacy for EMEA. We are a set of advocates. Our role is to be the conduit between developers such as yourself and the product teams. It's a two-way street. So we're really interested to hear about what your questions are, what your issues are with Azure and Microsoft platform. Whatever you speak to me, feed straight back into the product teams. We've got a booth here. If you want to pop over later on, you can meet me at the booth and meet the rest of the Microsoft team here. Or if you want to find out the rest of the cloud advocates, you can find us here. There's a link at the bottom. We specialize in all different open source technologies. I'm also an instructor on a platform called Udemy. Does anybody know Udemy here? Yeah? Any of you my students? Thank you. Thank you very much for your support. Last year, Udemy added in automatic subtitles, automatically generated, and they correctly pronounced my name as Awesome. So my name is Awesome. I've been using this slide for 2 years. I'm never going to stop using this slide. It's hilarious. So I also co-run a meetup in London called AI JavaScript. So between myself and my friend Eleanor Haproff. And we've been running this meetup for just over a year now, actually. The popularity has exploded. I think we're the 4th largest JavaScript meetup group in London, which is pretty cool. What happens at the end of every time we give a session in our meetup is somebody comes up to us and goes, oh, have you heard about this application? Have you heard about this application? Or did you hear about this? And so what we decided to do, we decided to collect all these wonderful examples of AI and JavaScript together in a website called AI JavaScript Rocks, so aijs.rocks. And if you go to aijs.rocks, what you'll find is lots of different examples of JavaScript applications, usually running in the browser, which somehow demonstrate some aspect of AI and machine learning. It's JavaScript, which still kind of means you can view source and kind of know what's going on, but it's JavaScript, so it means you can play around with it in the browser, you can look at the source code, you can see how it's working, and it always has links to at least a document or a GitHub to the source code. So it's a great way of seeing what's possible and then digging in to see how it was built. And for me and my journey into learning about machine learning with JavaScript, that's how I've learned. I've seen something cool, I've gone, how is that done? I've investigated it and I've learned that way. So what we're going to talk about in this talk is I'm going to describe 3 different applications. Hopefully it's 3. Yeah, 3 different applications that are on AI JavaScript Rocks. I'll show you how they work, and I'll explain how they were built a little bit. And through the process of those 3 applications, you're going to learn more and more and more and more about AI and machine learning. Till the end, you'll be an expert, and you can get a job as it. No, you'll just learn a little bit, and maybe you'll know a bit more about the space. So the first application, this one I wrote. I built this one. It's called the mojifire. It's not trademarked. It's just the mojifire. So I thought it was good, right? It's called the mojifire, and the mojifire does something amazing, spectacular. Don't. Just hold those thoughts for a second. What it does is you give it a picture. You give it a picture, as long as that picture's got a face in it, it will then detect if the picture has a face in it. It will then figure out the emotion on that face. And then can you guess? Shout it out. Mojifies it. There you go. That's what it does. That's it. Yeah, you know. Somebody. I gave this talk once, and somebody asked me if I'm open to investment. Yes, I am. I'm hunting for a seed round for this particular application. No, I'm not. It's had various different incarnations. The current incarnation I've created as a Slack application. So in fact, if you go to themojifire.com and you just click, that's a button you can't see right now, but that is a button, add to Slack. It will add it to your Slack workspace, and then you can use it just like this. So I've got a couple of examples. The first one is my son. There he goes. Beautiful, isn't he? And if you /mojify, that's him. Yeah, that's his look. The second one, it does work with multiple people in an image, and there you go, that's that one. And I've also answered a question that people have been asking for many years. What does Mona Lisa smile? Yeah, it's not really a smile, she's crying, okay? So I've answered all these questions. That's what the Mojifier does. It does a lot of different things, okay? But really, there's a good... The thing it does, I think, is the most impressive. I built it. I think it's the most impressive is how does it calculate emotion? Emotion. Now, I find it hard enough to figure out the emotion of another person. How can a computer figure out the emotion of a human being, right? And it's very easy. It's incredibly easy. Okay, it just requires 2 steps. Just 2 steps. The first step is you need to detect the facial features. Okay, the facial features. So now we understand there are some standard points which most faces have, that most of all faces have, and we know how to calculate them on each face. There are various algorithms which you can use, there's various ones, which you can use to grab those features. And they kind of tend to be just pure algorithmic computer vision approaches here. But you know, like the nose, I've forgotten what this is called, there's a bit here, there's like dimples, there are positions of the pupils and nose. If you can figure out what those are, that's a good start, right? Because if you're smiling, perhaps these points are higher, and if you're sad, perhaps these points are less, right? So you've got to first detect the facial features. And the second step is like really simple as well. You just use a neural network, and those are the 2 things. Just get the facial features, and you use a neural network, and that's it. Simple. Yeah? Do you want me to explain neural networks? Oh, okay. Okay, so what are neural networks? So I know no one knows. And what are neural networks? So neural networks have a basis in biology, in real life. Okay? Your brain is made up of billions of these neurons. And they're just little cells, and what you have is dendrites going in, a body, and axons going out. If enough electricity, just electricity, flows in through the dendrites, the body goes, oh, now I'll throw some electricity out to the axon. And that's it. If enough electricity goes in, some electricity comes back out. That's it. If you stick billions of these together, you get a brain. That's what it takes. If I was to ask you to code this up in JavaScript today, you could probably make a pretty good go at it. It's not incredibly complicated. Maybe you'd create something like class node, and it has some edges going in and some edges going back out, and that's it. Let's say we wanted to simulate something along the lines of, I forgot one example I used. Let's say we pump some electricity in, and for our example here, maybe this is the day of the year and the temperature, I don't know, something like that. And so, that's the wrong example. I've forgotten the example I have. But essentially, you pump some electricity in, and then you have some weights on each of these slides, which kind of tells you how important that particular bit of information is to the end result. You multiply it together, you add it up, and you pass that value through an activation function. Remember, the body, it doesn't just pass electricity through, it makes a decision about when to pass electricity through. That's the activation function. Then whatever it passes out, it gets passed out. It gets added onto another one, and another one, and another one. And just if you represented this like this, that's it. So all you're doing is you're taking some inputs, you're multiplying it by some weights, you're adding it together, and you're passing it to a function, just a standard function. You give it a number, it gives you something back out. That's it. And then that's the electricity kind of flowing through a neural network. There's many different types of activation functions. This is a very, very simple one. It's just any value that it gets that's above 1, it'll pass out 1. Any value it gets that's below 0, it'll pass out 0. That's it. It's very binary. It's not very good. But basically, you then connect loads of these together into a network. That's it, just a network. And so here's a 4-layer, very, very simple 4-layer network, one input layer, one output layer, 2 hidden layers, okay? And what you do is you then, each of those lines have weights. What value do you have for them? Just math.random, right? Give them a random number to begin with. And then what you need to do is you need to get some data. You need to train this, you need to tune this, you need to get some data. Perhaps what you have is you've got a data set of 10,000 pictures of people where you've extracted the features, the points, but then a human being has gone and said, that's a happy picture, that's a sad picture. Your training data needs to have the data and the labels. It usually has to have a human being who's gone through and manually given the correct answer. Okay, so your data is actually, this data is actually usually pretty expensive, and this is usually almost the most important part of any AI company is the data, right? The algorithms are less so. So we get that data, and what we do is we take those facial features and we pass them in as inputs. Maybe that's the X and Y coordinates of a pupil, something along those lines. We pass them as inputs. All that happens then is that gets multiplied, and it pumps a number out. That's all that's going on. Just pumps a number out. What does that number mean? I don't know. I'm going to decide that 0 means unhappy and 10 means happy, right? So my neural network right now for this picture is pumping out 3. But actually, I paid some human being who told me that this picture was actually 8. Some human being has gone down, I'm going to rate that an 8. So I know my neural network is wrong. It's wrong by 5. Of course it's wrong. I just did math.random. It's just wrong. It's just random, right? You're starting off from a baseline. So the neural network's wrong. It's wrong by 5. The secret to a lot of the explosion in AI and machine learning over the last even 10 years is the method of changing those weights to be better, to be different. That process is called backpropagation, okay? And it's essentially this idea that given how wrong it is, how do I tune? What's the best way of tuning those numbers so that next time it becomes better, right? That's what the secret is. And so that's what we use backpropagation methods to essentially tune those numbers so the next time it passes the data through, the same calculation gives 8. Now, you don't tune it once. You tune it 10,000 times, 20,000 times, 100,000 times. You take all of your pictures and you run it through again and again and again and again and again and again and again. And every single time, those weights tune a tiny little bit to become better and better and better and better and better and better. And that's it. That's all you're doing with neural networks and machine learning. That's the whole process. Okay? And you can do this. You can do this, and I've done this as well. There is actually when I said that the data is what's so expensive, like getting a good data with everything labeled, that's very, very expensive. There are public data sets out there which are available for research and training, or governments provide them. There's a really good data set out there for emotion, and there's loads of different faces, lots of different emotions. It's all pre-made. You can find it on GitHub. I should probably put the link up on here. Plenty of people have just used that to create an AI that can determine emotion, right? So that's what you could do. And that's what I could have used for the mojifire. That's what I could have used for the mojifire. But an important thing to do, especially when you're first starting out on machine learning, these days, and especially over the last 2-3 years, one of the big parts of this space has been taking very, very common problems, and turning them into APIs and services that people can use. Okay, so Azure, Microsoft Azure, AWS, Google, everybody's doing this. They're commoditizing common problems and making them available online. So actually what I used was the Azure Face API, which essentially does the same thing. We have our own data. It's not public. It's ours. But we trained up our own data sets, and you can just basically do a post request to some URL with a path to the image, or you can even send in the binary data for the image itself, and it'll return to you a whole bunch of information. This is a subset. It returns you a whole load more, where for each, it detects different faces in the image, tells you where the face is, because that's important. Because remember, we're replacing it with an emoji, right? And then also for each face tells you an attribute, emotion, anger, contempt, disgust, fear, happiness, neutral, sadness, or surprise. If you see the Microsoft booth today, you'll see a version of this where we're doing these things live with your face. From a value from 0 to 1, 1 being the most. Who here has a beard? Beardies? Yes? Yeah, so hands coming up. Yeah. You can't be 100% happy. It's impossible. I've tried. You can get to 99% happiness with this system, and that's it. Right? But essentially, that's what I used for the mojifire. So just to summarize, neural networks, they're incredibly powerful. But I think quite simple to understand. I think in about 5-10 minutes on stage here, I've explained the basics of neural networks. There's a lot more to it, but I explained the basics of them. And that's it. I suppose that's the summary from the first application. Now the next application. Okay. It's called Tensorflow, MobileNet, and I'm fine. So I give workshops on machine learning with Tensorflow. I've revealed a bit too much early, a slide there. I give workshops on machine learning in London. In one of the workshops, one of the guys, Oliver Turner, later on, they made a demo based on something that I taught him, which I love. And he made it's a code pen. You can actually go and, I don't know if you can see the pen ID, but you can go and try it out yourself. And this is what it does. So what it's doing is it's doing now a search on Unsplash, it's kind of image website, for puppies, getting the image back. So now it's doing a search for I'm fine. It returns this image, and the percentage at the bottom, that's what it thinks is inside the image. So here, if it does puppies, terrier 9.46%, bubble, it's got some bubbles in there. I'm fine. T-shirt, jersey, 78%. Nah, it's okay, right? The important thing about this demo, what's so significant about it, is that the only API request it's making is to Unsplash for the image. Figuring out what's in the image, that's happening in JavaScript in the browser, 100% in the browser. Okay, figuring out what's inside the image. It's using a technology called TensorFlow. Has everybody heard of TensorFlow? Anybody use TensorFlow? 3, 4, interesting. 5, yeah, excellent, yeah. So TensorFlow is a technology that was open sourced by Google in about 2015. It allows you to do large-scale mathematical computations on, if you've got multiple cores on your machine, multiple cores. It lets you use your GPU, like your graphics card as well, which are very, very good for doing lots of parallel computations. Also, lets you run on thousands of servers if you so need to, and it allows you to run lots of deep computational mathematics on lots and lots of servers. And what you saw before with that neural network, it's just a whole load of multiplication and maths you need to do. That's it, repeatedly. So TensorFlow is really, really good for training neural networks. But excitingly, TensorFlow itself is written in C++. C, it's like a binary. You have to download it and install it. So very excitingly, more than just over a year ago, they released TensorFlow .js. Don't we love it whenever the .js appears after names? Then we're like, yeah, I got a chance now. Yeah, I can do some machine learning. So TensorFlow JS, right, was launched. That's really exciting because now you can do machine learning with JavaScript. Now, the first thing I thought when I heard TensorFlow JS, I thought, you still have to install TensorFlow, and then the JavaScript is just there to speak to TensorFlow. No. TensorFlow JS, at least the browser version of TensorFlow JS, is completely rewritten in JavaScript. Everything. It's all rewritten in JavaScript. What does that mean to you? It means for you to start working with machine learning. This is all you need to do. Like an import or a script tag, that's it. One script tag, and you can start doing machine learning in the browser. Pretty cool, right? No other setup, nothing else is required. You can do, it doesn't have all the features that the full TensorFlow has, but it has a subset of it. You can do the training of the models, everything I showed you before, where you have a neural network and you feed it data and it trains and it backpropagates and it does that. You can do that with TensorFlow JS. You can. But what you can also do is load pre-trained models. So somebody else has trained up a model on maybe hundreds of thousands of computers over weeks, months, years, and then has saved that as a JSON file. And all you have to do is load the JSON file, and you can use it. Somehow I feel that we can relate to this as JavaScript developers. I don't know. But yeah, all you can do, as long as you can find a model that's being exported, you can then use it. And there's lots of pre-trained models that are available right now. If you go to TensorFlow JS, tensorflow.org/JS, you'll find them. And what Oliver used is one called MobileNet. So MobileNet is a image detection model that all you need to do is to give it this 4 lines of code, 3 lines of code well, 4 lines of code, import, get the image, load the model, and then pass the image to the model, and it tells you the percentages of what it thinks is inside the image. That's it. That's all you have to do. 4 lines of code to do that. But as you saw, it probably wasn't that good. Had 9 point, when you saw a picture of a dog, it thought a dog was like 10%. We saw a picture of the lady with the glasses and the jumper, it says it was just a t-shirt. It's not that, MobileNet is not that great. It's good, it's mobile, so it's optimized to be small enough to work, to be downloaded off the internet and work on a mobile, but it only knows how to detect 1,000 things in the world. That's it. 1,000 things. That's it. That's all it knows how to detect. There's more than 1,000 things in the world, by the way. There's many more. So that's all it knows how to detect. So it's not that great. It's useful for certain things, but it's not really useful. If you want to build an application which can detect if an avocado is ripe or not, you wouldn't use MobileNet. Okay, you need to have something a little bit more in depth. Those models that are usually a lot larger, you can't really use them on mobile. So usually services that you can use, such as, any guesses? Azure. Correct. We have one. Computer vision. I don't know why we have a picture of somebody who looks confused on all of our marketing sites. I think we should have a picture of somebody who looks like, aha, I get it. Yeah, so computer vision. It's the same thing. It's like an API request, and you can pass it your image, and it will give you lots of information about the image. Lots and lots and lots of information about the image. But one of the things it gives you that I think is kind of amazing is that it gives you a human-readable description of the image. A human-readable description of the image. Okay? And one of my friends, Sarah Jasner, created this code pen to demonstrate it. Does anybody know this film, this TV series? Yes? Anyone else? Yeah? *Halt and Catch Fire*. One of the best TV shows I've ever watched. It's about the birth of computing and the internet. So it starts in 1983 or something, and it goes like 1992 or something. So it's beautiful. You see our history. I haven't actually watched the last episode. I've never watched the last episode. I will never watch the last episode of this series. That series will never finish for me. But anyway, the character in the middle she's one of the main characters, Mackenzie Davies. She's the actress. So when you give it this image, the API returns you Mackenzie Davies et al., which means and everybody, standing in front of a building. The API gave you that as a description, right? Not a woman, but Mackenzie Davies, the actress. Think of what it has to do to figure that out, right? Kind of crazy. So as you can tell, this API does a hell of a lot more than MobileNet. But as we know, people on the internet are very, very friendly, very supportive of other people in the world. And when Sarah posted this on Twitter, some people very helpfully told her that it doesn't always work. So this is one example when it didn't work. So that image returned a star-filled sky. The text says some characters. Don't know. So that didn't work. The next one could be true. The next one could be true. I mean, you don't know, do you? Those could be dead cats stuffed. You don't know. You're not 100% certain. Okay. And the next one is pretty good because I think we were half right in the next one. Yeah? Man and a dog? You got a dog? Right. So okay, it doesn't always work. But it's still pretty incredible that this stuff works at all. I think in 2010, we still couldn't detect if a picture was a cat or a dog. That's where we were like 9 years ago, and this is where we are now. So to summarize, if there's one takeaway you take away from this meeting, from this session, is that Tensorflow JS doesn't have any dependencies. So if you want to start playing around with it, if you want to start exploring this space, that's a really good place to start exploring because you just add a script tag and you can start coding. MobileNet is a very simple way to analyze images. When I do my workshop, I start people off with MobileNet because it's a great way to just introduce yourself with this space. But if you really want to do any kind of deep image analysis, probably a good place to start is using an API, and I'd probably start off with the Azure Computer Vision API, which is actually a very, very good API. It's a very good API. All right. Last demo. This is my favorite demo. Oh, yeah. Image to image. Again, all of these you can find on AI.js Rocks. All of these you can find on AI.js Rocks. All right, the best way to explain image to image is just to watch a video. Okay. So, what is it doing? If you draw an outline of a cat, it fills in the rest of the cat. Okay, now this is working in the browser. This is working in the browser. You can do it. You can try it yourself. Okay. And there's other versions of it that work with other things. It's made by a gentleman called Zaid. He's still in university. What was I doing in university? I wasn't doing this, right? He's still in university. I don't think he's going to have a problem getting a job. Let me put it that way. So if you want to, you can find he's got lots and lots of stuff. You can find him on his GitHub there, and I recommend following him if you can. So what this does is it uses a technique called pix-to-pix. Which is based on a neural network, and it's based on something called a GAN, which is a generalized adversarial neural network. Oh my God, hang on. Sorry, not generalized. Oh, oops. Generative adversarial neural network. It's adversarial because there's two neural networks that are fighting each other. All the time, they're fighting each other. Okay, it's just adversarial. And it's generative because it generates stuff. So how it works is this. You've seen this before. You know what they are. They're just nodes and edges and weights and randomized things, right? So you start off with two. One is a generator, and the other one is a discriminator. Generator and discriminator. The generator's job is you pass it some inputs. Remember, you pass it some inputs into the input layers, and it generates something to the output layer. So maybe you give it an outline. Maybe you have like 10,000 images which are outlines of cats, and you pass it in, and it tries to generate an image of a cat. But it's not going to do a very good job of outputting an image of a cat because it's just random numbers to begin with, right? It's probably going to give you noise. But whatever, you don't care. You take all of those, you merge it with some real pictures of cats. Maybe another data set of 10,000 cat pictures. You jumble it all together, and you pass those to the discriminator. And the discriminator's job is basically to say if an image is of a real cat or a fake cat. That's the discriminator's job. That's all it has to do. You pass it an image, and it goes fake, real. That's it. But the discriminator's not going to be very good as well, is it? The discriminator is random numbers. It's not going to be very good. It's going to get it wrong most of the time. So the discriminator might get it wrong. It might say the real cat is fake and the fake cat is real. And when we know how wrong a neural network is, what we do is we backpropagate and we optimize. So if the discriminator is wrong, then it tunes itself to become a little bit better next time. If the discriminator is right, then that means the generator is not doing a very good job of generating cats. The generator has got to get better at generating cats. So the generator then optimizes, becomes a little better. And that's what happens. You don't actually need labeled data here. You don't need a human being who's gone through and kind of said this is a real cat or a fake cat. You don't need that. That's not what's going on here. So you just get some outlines of cat images, and that's your data. And that's what happens. The generator gets a little bit better at generating cat images. The discriminator gets a little bit better. Then the generator gets better. The discriminator fights against each other all the time, until eventually the generator does such a good job of generating cat images that the discriminator can't tell anymore. It just can't tell if it's fake or real. Then you kind of stop and you throw away the discriminator. We don't need the discriminator anymore. We need the generator. So you throw that away. You export that as JSON. Okay? Remember, you can load JSON and you can load pre-trained models. So you export that as JSON. You load it up in the browser, in the web page. And that's it. That's what you do. Then your human being can draw in a canvas, and it will figure out the rest of the cat image. That's how it works. That's a GAN. It's pretty cool, right? What's the point? What's the point? What's the point of, it's just going to generate, what is the point of generating cat images? What's the point? Well, the thing is, it works with all kinds of different things, not just cats, right? Now people start getting scared. Yeah. So the image on the colored image is the output. The input is the outline. Okay? But this isn't pix-to-pix. This isn't a pix-to-pix algorithm. This is the vid-to-vid algorithm. Okay? This isn't working in the browser yet. Okay? But there it is. Generated. How about one input, multiple outputs? Yeah? The input doesn't have to be outlined. The input can be anything. The input could be anything. You're creating a neural network which, based on some input, generates something. Anything, really. But based on some inputs, it's going to generate something. So the inputs could be a segmented image. So the input is on the left, and the color gives some information about depth and like the 3D nature of the image. And then you can generate stuff like that. So she's not dancing. That faked it. That's all fake. Yeah? It's generative. This is an interesting one. They've done this with it's a segmented image of a car scene. There's multiple different algorithms. The one on the bottom right is the vid-to-vid one. That's the best algorithm. You can see it's generated. That's a generated image, a generated video. Yeah, it's not real. It's fake. And as I said, like, it doesn't have to be. It doesn't have to be an image. The input doesn't have to be an image. The input can be anything you want it to be. The input could be text. Text. So this is one, which is the input is the text at the top. This flower has long, thin yellow petals and a lot of yellow anthers in the center. The stage 1 is after 600 iterations. It's not that great. It's pretty good. Stage 2 is after 1,200 iterations. This one isn't very good. But the rest are very good. And this one is birds, right? This bird is white, black, and brown in color with a brown beak. So again, these are after 600 iterations. This is after 1,200 iterations. Pretty good, right? Pretty good. Oh, that's not good. But whatever. The rest are pretty good. That's it. How far away? I told you, like 9 years ago, we couldn't tell if an image was a cat or a dog. How far away do you think we are from a human being just writing down, build me an e-commerce website, use this as a reference architecture, I want to use Microsoft Azure, default color blue, go, right? How far away do you think we are from there? Now everybody gets worried. This is brilliant. I did do this once at a conference, and somebody shouted at the back going, "We're researching that." Anyway, so summary. GANs learn to generate new images or new things, okay? That's what's so cool about them. They're generative. They're very artistic, because other AIs will tell you, this is something and this is not something else. Generative ones generate stuff, so they're very artistic. Some of the stuff there's a lot of artistic AIs that come along now that create music compositions for you, that do all of the things. They're generative, okay? They're generative. They take a lot of computational power to train, a huge amount of computational power to train. But it's not going to be feasible to train this in JavaScript. But the generator model can be exported, and if you optimize it carefully, it can be small enough to run in the browser. So there's some very interesting stuff that's happening in this space. Before I finish, it's a quick thing. I am writing a book. It's definitely going to happen now. If you want to know when, if you want to get some information about when it's going to be released, just go to there and sign up. If you want to find out a little bit more about how to build these applications, especially on Azure, if you want to build your own mojifire Slack bot, which does something else, like puts a hat on someone's face or glasses or whatever else you want it to do, you can go to that link there, and I have a whole tutorial, step-by-step tutorial online, which will take you through everything, including all the Slack stuff and setting up a Slack app for building something similar online. And that's it. Thank you very, very much for your time. That's an old slide. Anyway, thank you very much for your time. Cheers. Bye. Oh, I forgot. I forgot. Sorry, I forgot. I'm going to answer some questions here now. If you want to speak to me later on, I'll be at the Microsoft booth, and I'm happy to answer questions on anything. We've also got some lemonade and beer, which, yes, lemonade and beer, which is available for you if you join our developer community, which you can do at our booth. So yeah, I'll be at the booth later on, so come see us then. Okay, thanks. Question time. Oh yeah, and more applause, more applause. Come on, yes. Thank you.
Thank you for the presentation. The question is, does Tensorflow JS use CUDA or GPUs or no?
Yeah, if you're running it in the browser, it goes through WebGL and it uses the graphics card. TensorFlow JS, I missed this completely out of this talk, but it also is available as Node. And when run as Node, by default it doesn't, but you can install some packages which will use CUDA as long as you've got those packages installed. Yeah. Which is like a graphics, it lets you do, anyway, yeah.
Anyone else?
Yes, we have one.
Not really technical one, but it has appeared in my mind. Like recently, it was a movie when the guys who were that De Niro were like younger.
Oh.
So probably it is like that technology was used.
I actually don't know. That's a good question. I think you're talking about Gemini Man with Will Smith.
I don't know. Kind of that.
Yeah, I think that's the one where where it's him as the older actor.
Al Pacino and De Niro, and so they've made like their faces like younger.
Oh.
They just took off all the facial.
I don't know what
So
that would.
My question is another one. Like it's more like a bit political because some politicians they are already saying that they haven't told any like some stuff or abuse stuff, and it was like a computer simulation.
Yeah.
So kinda it is like can produce some fake news.
Yeah.
So for like.
Well,
to eye, how should I recognize the fake?
I showed you some scary stuff here.
Yep.
Yeah. Here's what I believe. And there's even more. There's other things. There's this thing called deep fake, where you can take someone's face and put it on another video. That's actually not machine learning, believe it or not. That's pure algorithm. That's a pure computer vision algorithm where you use it's a very crazy algorithm. You can actually just swap people's faces. But generally, what's happening is that it's becoming harder and harder to trust what we see on the internet, which is, and I think it's going to get worse. I think it's going to get much worse. Which is why I think face-to-face interaction is going to become more important. I know you're real because you're there, and I can see you, and I won't touch you.
Cannot be sure.
I said that I gave this answer before, and then somebody goes, "Until the robots appear." Yes, okay. I think for now, face-to-face interactions are going to get more and more and more important in terms of real human connection, and which is great to me because it's going to de-emphasize a lot of, I think, is the uglier part of the internet, and make these human connections a bit stronger. That's my dream. Yeah, fingers crossed.
And the second question, Firebase, they have out-of-the-box face recognition about languages, some stuff. So, and they made it even offline.
Sorry?
Can Azure make the same,
say it again, sorry?
Offline model, models already working offline?
Yeah. So we actually can, Microsoft Azure, because one of the things that you can train your own models, and you can have that offline on your computer and run it that way. What we've got is all of our APIs are available as containers, which you can use via some licensing, because we don't want you to steal all of our data, which you can use and download and use on your computers or on your private networks without going out. So all of our APIs are available as containers. It's called machine learning on the edge, and you can get it that way. So that's one way. I think, has that answered your question? Yeah.
Thank you.
Oh, another one. They're all coming thick and fast now, yes.
Hello, thanks for the talk. Regarding that discriminated network that you described previously, as far as I get it, we have two images passed in them. One is the real one, and the second one is
In the
generated.
GAN, yeah.
Yeah. Isn't there going to be an overfit problem?
What, sorry?
Isn't there going to be an overfit problem where the discriminator gets overfitted and biased to the, yeah? Yeah,
I imagine, well, not necessarily, well, perhaps because there's real data and fake data, but I don't know if I should, overfitting is this concept that a machine learning algorithm just learns what's the good data and what's the bad data and doesn't learn how to discriminate. It just goes, oh, the file you sent me is real.1. Oh, maybe this is the real image, and sends that back out, something along those lines. Yeah, I don't know. You're right, but as with anything, there's loads of different techniques that you use. You randomize the data, you randomize the order, like various different things like that. Maybe you would only send, maybe you have like 100,000 images of real cats, and each time you take a random set of 10,000. There's like various things that you can do to kind of avoid that approach. But I don't, yeah.
Okay,
yeah, it's a good question. Yeah. Oh, another one. Ooh.
Hey, thanks for the talk. I heard that there are several ways to learn the model, like random forest, and that's all I know.
Yeah.
So basically, does it depend on the data set or the aims we are going to? Yeah.
Yeah, it's based on a lot of different things. If you're starting off, the best thing to do, I don't have a link right now, but if you go online for a common set of problems, there's kind of very well-known architectures and algorithms that you should use. And like what's happening, like a lot of people, like a lot of my colleagues who are very, very deeply into machine learning, they're just reading PhD theses every single day. And what people are doing is they're going, to solve this type of problem, I tried this architecture and this approach, and I got 0.2% better. So that's where a lot of it's going on. But to start off with, I wouldn't particularly try and invent your own, or maybe if I use 15 layers with this algorithm, try and pick or start off with one of the well-known ones for doing kind of image classification. There's kind of well-known ones that you can start off with, and then go from there is what I would state. Yeah.
Thank you.